Okay, so good morning, everyone. Again, uh, thanks for joining the session. Today, the plan is we will go through there are 6 stock buy sell problem in Leetcode, and we will see how much we can cover today. So that's why I will first go through the agenda. I was thinking, what is the best way uh, to approach different problems, and this is the idea I have come up with. We can tweak it, but we will see as we go. Like, so first thing is, first of all I would like to acknowledge this guy whoever wrote this thing, because if you have gone through this, it's great. You may find a lot of ideas are directly from that. So yes, it is. If not, I would highly recommend it. And I think after this session, if you go through it, it would hopefully will make more sense, or it would be ideal if you don't need to go to it. That's at least my, my expectation from this session. We will see. Anyway, so we'll start with stock buy sell problem, first problem, and then we'll go through some unrelated ideas, like very easy approaches. So I will go with idea one. There is a cadence, I'll go for that. Then there is a divide conquer approach. And then we will go through some DP approach, which will start this approach, like Leetcode thread I was discussing about. Then we will solve in 3D. And that's it. Because I don't want to go to the space saving solution, because like a lot of people, once they have the state diagram or the transition functions, it doesn't take too much effort to solve the problem. And this solution works. So we'll do that, but we'll do that later. Same thing we will do with buy sell problem 123. So see, after 121, I'm going to 123. I'm not going to 122. So these are a couple of things. And once we will go through all these problems, then I will go through the general idea or example of space saving. Maybe we'll go through Fibonacci example. In fact, today's Leetcode problem, Leetcode challenge, we can apply that space saving approach there too. So we can do that one. Then there is a knapsack problem where you will see 2D solution, then 2-row solution, and then just how to do 1-row solution. And once we will have that background, we'll try to apply them to all these problems one by one. So one thing, if I have to just do this for these 6 problems, I can totally get rid of this section. Actually, I can totally get rid of this section. So, and this is also a little bit advanced topic, in my opinion, at least. So we will see how you guys want me to approach the problem. But that is how I was thinking would be the best way to go and solve these problems. Does that make sense?
Can you please share the first link on the chat?
Yeah, it is also on Leetcode thread, if you haven't seen it.
Thank you.
Yeah, so we can do that. It is on the Leetcode thread, by the way. So do you have access to Leetcode practice?
Yes, yeah.
Yeah, so if you will click here.
Okay, yeah, I got it. Yeah.
You got it, right?
Thank you so much.
Yeah, no problem. Okay, with that, let's start with problem 1. So the first problem is best time to buy and sell a stock. You are given stock price on a particular day, and you can buy on day I and you can sell on any day after that day, but not on the same day. And you can make at most 1 transaction, and you have to tell what is the maximum profit you can make. So in this example, as you can see, 715364, we can make maximum 5 profit. And I will draw a graph anyway, so we'll explain it. And if the price is decreasing, for example, then you would choose not to do any transaction. So in that case, maximum profit will be 0. Okay. And also just to give you a glimpse ahead, you will have access to all these approaches, solutions. So don't worry about it. All these approaches, there are so many approaches I think I may have here. I will share anyway. So just try to understand and then we'll see. So the first problem, you are given something like this. Now I want to draw. So when I want to draw, I
Yes.
would click here.
Yeah.
Okay. And then I can start anywhere. Okay. And I also want to space save. So I will try to do like this. Okay. So the price is 715364. Okay. So the price is, for example, okay, so I have to choose something, maybe this one, 715364. That's the price for different days. So normally I like to draw a graph. I'm a visual guy. I understand more when things are like this way. So 7 to 1, then 5, maybe 5 is here, then 3 is here, then 6 is here, and then 4, okay, maybe 6 is here, and then 4, make 7 here then. Okay, 7, 1, 5, 3, 6, and 4. Okay, so at which point of time do you think you would like to buy, and of course, when would you like to sell? You can do one transaction,
1 and 6.
1 and 6. Yes. Why? Because 1, we have least price on 1, and then we can sell on 6, because 6 I could have sold on 5, but then I would make less profit. So it makes sense to sell on 6. So that's a good approach. And what normally, in some of the problem when you like to visualize things, this thing can work, and then we will see why it works here. I want to find the minimum price when I am going from left to right, because right is future, left is slowly going to be the past, right? So in future, I want to see what would have been the best price, right? So from this given array, I would have created maybe a left, left view of this. Okay, what would have been the minimum price? So on this day, I would have 7 as max minimum price. On this day, next day, 1 would have been the minimum price so far. On third day, still my minimum price would have been 1, right? Does that make sense? Because I could have bought anyway on a less price 1 day before. So we can continue making things like this. And then from right side, we go in this direction. On left, from left side, I was going like this. Now we go from like future to past this way. And what I want, what would have been the best price, best stock price so far, because then I could have chosen that day to sell it. So from right side, I could have done, okay, maybe 4 so far, then 6, much better. On 3, I would still say, hey, I would choose 6 rather than 3. And then again, I would choose 6 because 5 is less than 6. And then 1 again 6. And then 7 again, I would choose 7 actually. Right. And your solution is what? Like the best solution would be, what is the best price I can get? Actually, did I make a mistake? because till this day, till this day, and then 3 would have been the best, right? Okay, so how do I erase it? Because I can't sell on price 6 on this particular day.
We
Yeah.
do we need to go from the right? We can go from the left, right?
Yeah. That's the space optimized solution. I was just trying to see why it helps.
Oh,
We are going from right to left because I will see what is the best I could get.
Eraser is just below view.
Okay.
You can click on that and yeah.
This one. Okay. Yeah.
Now you have to click pan again. Yeah.
Yeah. I will just see whether I can use any information or not. So I could 4, but yeah, then it's problematic. Yes, you're right. Because now 4, when I put 6 here, I would rather have 6 here. On the 4th day, on the last day, I could also sell that, right? Yes. So doesn't make any sense here. So we'll just see what is the best price I could get. Okay, so let's do that.
Roger, that also makes sense, right? Why it doesn't make sense?
So on the last day, you can do 4, right? But now go to learn previous day, which is 6, right?
Yeah.
So 6, that is very important. What do we choose here? If I choose 6 here, I mean, we can, we can say 6 is the best. We can again say 6 is the best, 6 is the best. And then here 6 is the best and 7 in the here. And then we can we can make sure, okay, what was the best, go and choose all these indices. What is the best you can do? And you can get a solution, right? And whatever
Right.
is the best solution is 5, 5, 5, 5, 3, right? So this works, but only thing which conceptually I didn't like, unfortunately, was here when we are making 3. So yes, implementation wise it will work, but we could achieve the same, or actually same thing, if we go from left to right again. And instead of that, I do see 7 would be 7, right?
So what does that mean if when you say you didn't like 3? Like, is it wrong or?
That's not a final answer.
No, my final answer was the best among this, right?
Yes.
Yeah. So we have the answer. I'm not saying we will not have the answer. Yeah.
Yes, I also have the same question when you said that 3 is not good here.
Like, is there any scenario which you think that it will fail, or?
No, it
I mean,
will not.
Just trying to understand or brainstorm, like what you're thinking when you say 3, you don't agree with that value 3 at the end.
Somehow, I look at that, it seems like, if we do in this way, we allow to sell, to buy and sell on the same day. If we look at the column and we get the best, including today, then wouldn't that mean that we buy and we sell on the same day?
We are, which, okay. No. So that's that's the detail, on ith day when you are looking, you will not actually look like that. So you will look something like this, right? Right? Because you will have to first own it and then you can sell it.
Okay.
Right? So for example, for the first day, I cannot even make 0 because I have to first buy. And then on the next day, I can make a loss of -6 if I decide to, right? So the thing is, in this, these approaches, we are going to discuss, the ideas. What I didn't like about this particular one was conceptually what I was thinking, what is the best value to sell till this day? That is what I was thinking. So when I was thinking that one, then this 4 doesn't appeal me, because this was my first day, this is second day, third, come on, second, third, and so on. So on this day, if I am saying that, hey, the best day, like, best price I can get, like, till this day is not 4, actually it would have been 6. But if I say, what if I sell on this day, what will I get? Then yes, then that works. Then actually this, like, understanding holds true. And I think that is what you guys were thinking, right?
Yeah.
Yeah. And yes, I think, yeah, that should be the way. But yes, we can change the, like, way how we, like, define things. If I define it in a different way, then I would actually change my, like, going from this side, and I can kind of, like, make a different definition from that side. Does that make sense? At least, did you understand why I was saying, like, I don't like this one? It was not like, you won't get the answer, you will. But when I was thinking about it while drawing it, my definition was different. And my definition was not like, I didn't like that. But yes, this will work. And that should give you one of the answer, one of the possible way to solve this problem. So we have too many ways. So what I will do, and I try to do something to save your time. I don't know, is it Leetcode 121? Okay. This is the approach we are talking about. It also optimizes the space. So basically we are doing the same thing. We are finding the minimum. We are going from left to right. We are not creating the array as I was showing, but I mean, this is the optimization of that solution. You keep going, you continuing with the minimum price you have seen so far. And then every time you are able to make a profit, you will see, hey, is it the best profit I can make? If yes, then let me update my result. Otherwise, just forget about it. So that was the basic idea. Like, after you optimize the space, we will derive the same solution. Okay, so with that, if there is no question, I will go to the next one, which is cadence algorithm for this, very fast.
Yeah.
Okay, I think we are good. So now I want to erase everything. Is there a way to erase? Okay. Is there a way to erase the whole page?
Make the new page, I think.
Yeah.
Oh,
There's,
then I have to do new page. Okay. I don't want to erase this one. Yeah, this was probably 7. Okay. So the next approach, we want to talk about cadence algorithm and why so, first of all. So let me, draw this thing. Let's call it x0. Let's call it x1, x2, x3, x4.
So we are doing the same problem with a different algorithm. Like I joined a little late, so I don't know what
Yeah.
we are trying to do. Okay.
Yeah, these are the approaches I like. We will go very fast, but just to, like, let's go through it.
Okay.
Yeah, that was not the core idea of this session, but anyway. So as somebody said, what we want to calculate is 6 minus 1 in the previous approach, right? So here is that thing going on. Can somebody tell cadence algo, it is used for what?
maximum sum subarray.
Perfect. Maximum sum subarray. Okay. What I want to calculate in this particular case, eventually I want to get x4 minus x1, right? x4 minus x1. So x4 minus x1. Okay. And the thing is, the idea is here, if we create a, like from this given array 7 1 5, is it 3? Yeah, 3 6 4, another array which is basically like a difference of the neighbor, then we can apply maximum subarray, and let's see how it will work. So the first one, it has no neighbors towards it left, so let's call it 0. I don't know, why can't I draw it? Okay, 0 minus 6 and then 4 minus 2 3 and minus 2. Okay, so let's look at the maximum subarray. What is the maximum subarray value? We normally go from left to right. If there is any, as long as you see positive value, that is your candidate, because it can give you something better in future, right? So 0 is fine, but as soon as we see 6, we say, hey, let's drop it, because in future it will only make my value less. But 4 is good. Even minus 2 is good, because 4 plus minus 2 is still plus. 3 is good. And what I have made till this time is 5. And then minus 2 is also good. Total is 3, but I could have made here itself 5, right? So as you can see, this works. If I turn this array into another array, which is the difference of its neighbor, and I just calculate maximum sum subarray, it works. Now why it works? Because all what I did here is x4 minus x1, right? So x4 minus x1, can I write it x2 minus x1 here, plus x3 minus x2 plus x4 minus x3. I think this part is totally insensitive. I can't write x3, but yeah, somehow I can. So okay, let's look at it. x2 minus x1, so this crosses. x3 minus x3, this will get crossed, this one and this one, and you have finally x1 x4. So x4 minus x1 you have, right? That is what we wanted to get. So the idea is, if you know the delta, like every time you know what is the loss I can make versus what is the profit I can make, and if you find the maximum sum subarray, you will eventually find that value here, in this case here to here, and that's one of the solution.
Yeah, Roger, can you tell how did you make how you create the value like 0, -6, and 4?
Oh yeah, so look at the left neighbor. So for 7 there is no left neighbor, right? For 1 minus 7 is 6. For 5 minus 1 is 4. For 3 minus 5 is minus 2, and so on.
Okay.
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 And again, in this particular case, just for explanation, we are creating an array, but you can implement it without actually creating this array. And that's the idea, which you can keep and look at it later, but this is what is going on here. It's a simple code. We just do max current, it creates the delta, and then we calculate what is the max current every time. If it is negative, we want to drop it, as you have done already in maximum subarray problem. Exactly same algo applies, and you keep updating your max so far, and finally whatever is the best solution, you just return it. So that was this approach. And then finally, before we move to our actual thing, I will very quickly would like to go to the divide and conquer approach.
I have a quick question on this Kadanes algorithm, if we can
Sure.
stop for a bit. So the second array which is created, which is looking at the left neighbor and then subtracting from it, how would you describe that array? What does that array really mean?
That array means your delta from the previous day, right?
Okay,
The daily change of a stock price.
I see.
Yeah, so when you have daily change of a stock price, and you can start from anywhere to anywhere, as long as you can maximize that, don't you think you will get the best result overall? Because
Okay, yeah.
yeah, so that's the thinking about that approach.
Cool. Yeah.
All right, so let's go to divide and conquer approach very soon. This was clear, guys?
Just a quick question, another
Sure.
quick question about the cadence algorithm. So you said that you're not using that additional array, right?
Right.
So are you modifying the input array, the prices array, or do you not need to do that either?
I don't need to, because every time I was only looking at the left side of the neighbor, right? So when you have only one value, you can try to optimize it as I did here. You just already have price I and price I minus 1. So you don't need to create that. This one highlighted line. So as you are moving from left to right, you have that whatever you would have put in that new array, that value is nothing but this one. It doesn't change, right? Every time you will have a new value, but there is no change there. So there is no point to store that.
Okay, cool.
Great. So with that,
No,
any other questions?
no.
Great. So, okay, now just one idea. So you have this value. I don't know why can't I, everything is against me today. I can't draw anything. I don't want to use.
Oh, it is because eraser is selected.
Oh, thank you. Bhavesh, you are so helpful. Thanks. 715364. That was the value. 715364. Now think about it. Suppose I want to, these are actually different values. It's not one value. So just think there are commas in between and all. So now this approach is saying that what if I break in between and get the best result from both the sides? So something like this. This guy will ask, okay, can you give me value for 715? What is the best you can get? What is the best you can get? 364. Then 715 says, okay, let me break again. 715. 15 will again say, okay, 1, 5, something like this. And here also we will have 3, 6, 4, and then again 6 and 4. Okay, so if these guys, for example, I like this place, suppose magically magic of recursion gives you the best value here. Like 715 gives something that, hey, this is the best value if I only do the transaction between this time from 7 to 5. This gives you, if you do the transaction means buy and sell during this time, this is the best you can get. So, okay, one thing I can get, I can do maximize. Okay, whatever is the best value, that is one possible answer. But what if I bought something in this area, somewhere here, and sold in this area? So you need to pass that information also. Something like, what is the least price in the interval which I am catering to? So it can also send, hey, if you want to take my profit, this is the best I can give you, my profit. Next, by the way, here is the best or best, like minimum price in the interval I am catering, say something M, and here is the maximum selling price, let's call it as something like this. So if we pass these results up like this, we can get a solution, right? And these guys are base cases. So yes, on 6-4, like you can't make, if you have just one day, you can't buy and sell. So most likely 0 or something, but you can continue sending this information up the chain and you can still get the solution. That's the idea of divide and conquer. If anyone has any question, feel free to ask.
So what do we gain? Like, when do we use this type of approach? What do we gain with this? Because this will be also the linear time, right?
Okay, so the thing is, we are talking about different approaches, and we are just like, I'm saying like one problem can have multiple approaches, and sometimes maybe not in this particular problem. Maybe if you know.
Yeah, that is what I wanted to understand. Like, when do we use this type of this
Yeah,
approach?
so yeah, for any divide and conquer approach, whatever is the the standard book says, like, can you divide the problem, right? Was this problem dividable? Luckily it was. Can I make, based on the sub problem, can I
Okay.
still merge the solution, which we could, right?
Yeah, got
So
it.
we can go with that. So
Can you repeat the information you're passing at each level again? Like the profit from.
yeah, profit. So what profit, if you just take my answer, this is the profit I can give you. What is the minimum price during the range I am already covering? Like, in 715, maybe you will pass 1 is the best or minimum price, and 7 could be the maximum selling price, but I don't know whether 7 would be there or not. Something like that. You pass up the chain and then you merge from both sides. And when you merge, actually there would be an important thing, because now from left side you can only take the buying price, right? Because you can't buy on right side, right? And you can't sell on left side because the days are like sequential. So your minimum value is important from left side, and from right side your selling value. Here
It is
is a
not
quick
always correct, right? If we have 716354,
716364. Oh yeah.
354, 716354, then how do we do that? We will get both minimum price and maximum price on left side itself.
Yeah, so we are also having that one, right? So this guy can choose anything, right?
So we don't have only price, but we have a profit also.
Yeah,
So in
this
that
one
case,
was
we will
profit.
choose.
This one. So
Okay.
yeah, first one was profit. If you just take this guy's solution, that was the first thing. That was the profit this guy was that could make. So in your example, 716, yes, 5 would have been the best profit here. And since you guys like code, why not? Here is your code. Max profit. You are doing just 0 and -1. There is a helper function, and these are the 3 values we are passing. And we are getting the solution from left side, right side. We are getting the answer from both sides, and we are creating this 3 values which I just talked about. So the idea was to give you the idea, and as I already talked about, that you will have access to this solution, and I'm pretty sure most of you can debug it or go through it. So if there is any conceptual question, feel free to ask. Even coding question you can ask, but I don't want to go into the debug loop as we have so many things to cover. That's the only reason I don't want to.
This is really a unique way of doing it. I really liked it. Thank you.
Yeah, no problem.
So like the techniques that we've discussed so far, like cadence algorithm and divide and conquer, like are they generalizable to the like more complex variations?
Yeah, I don't know actually. Yeah, as you do more problems, that's the intuition that may come. Sometimes intuition comes after looking at other solutions. So yeah, try to find different ways to solve the same problem, even if you have solved it. And then in certain situations, you may apply that, right? So, I mean, that's it. So let me look at my agenda.
So one question I had, like whatever you have drawn, so can we visualize this as like kind of a subarray, because all the nodes is more or like they are the subarray of the original array, right?
Yeah.
Okay.
Yeah. When I try to visualize, I personally think as a tree, because what I am doing, I am breaking in between, right? And kind of we are doing post order traversal kind of thing. And that is the well-known technique, to solve many problems. So personally, I visualize like that.
What's the time complexity for the divide and conquer approach?
So what do you say? What do you think?
I think when you divided the whole array into 2 parts and split until have only one element in array, I think it's a linear time complexity.
Yeah, it is. It is. I think it's a linear time complexity.
Okay. Yeah.
So yes, with that, okay, let's erase this. And I think now we can go to our actual, problem solving ideas using dynamic programming. So guys, this was useful, right? Even though we don't want to solve using this, I hope you may use it somewhere else. So we covered, I have already acknowledged this guy, great. Idea 1, we went through that, cadence algo, divide conquer, possibility of DP, and then, okay. So now we can go through the DP approach. For DP approach, we want to figure out what is the state. So in this problem, now what we are going to talk about, the state of this problem, and we'll try to go through the same, we already know the problem, by the way, so I don't need to write that array anyway, just to derive the solution. So what is important here? You are given stock prices, something like, okay, let me try to something like this, forget about what is the value. What is the importance of on any day? What is unique about it? Suppose you are here on ith day. Day will only increase. So you are here on ith day. What is important? What you can do, the options you have on any day is you can either buy a stock, you can sell a stock, or you can choose to do nothing, right? You have three options. Okay. And then also, not only that, we have a restriction that we can only do one transaction in this particular problem. But since we are going to do generalize and we don't have too much time because, we already know the questions in future, we'll try to already generalize here. And maybe we will reuse that idea in future problems. Okay, so actions you can do, you can sell, or actually you have to first buy, sell, or you do nothing. No op. Okay. Okay, so what is the result of buying, selling, or doing no op? If I don't have a stock, then I will have a stock in hand if I buy. If I have a stock and I'm selling it, then I will have zero stock after I sell it, right? And if no op, so if I already have a stock and I did nothing, then I will continue to have that stock. If I have zero stock and I didn't do anything, then I continue to have zero stock, right? So this operation, all these options can lead me to two state. Either I can continue to hold zero stock, or I can continue to hold one stock, or maybe I can switch between 0 and 1. So the end result is how many stocks I will have in my hand, either 0 or 1. Does that make sense so far?
Yes.
Great. All right. And what about the restriction? Suppose your graph was something like this, not like that color, but anyway, if your graph was something like that, then you would choose not to buy because you will make a loss, right? Because price is decreasing every day, then why would you buy? And also the problem says that you can make at most one transaction. That means that includes you can make 0 or 1 transaction. Number of transaction, you can either make a maximum of 0 or 1 transaction. So what is changing here? Your days are changing. Every day I will from 4 to 5, 5 to 6, something like that. Your whatever you are holding in the hand is one which may change. And what is important for you also, that on that particular date, how many transactions you have already done. So if you have a unique way to define these three things, then you have a valid state. So with this, we can define our definition basically. What is the, when we create DP arrays, we should understand what does that mean. Then we can figure out the transitions easily. Okay, so let's do that next. Okay, so yeah, if you have any questions, feel free to ask, because if you understand this, I think you can solve, I think, most of the problem in this session. So let's call it DP I Then let's call transaction first. And we have a K transaction problem. So let's call it here K. And then how many stocks we have in the hand. Either we can have 0 or 1, right? So I could have also made another array, but what I have chosen, I will make dpik0 and dpik1, which will mean the same thing. So let me first define this, then I will define the next guy. So on this day, suppose I'm defining my dp array. My definition is what is the maximum profit I can get. So let's call max profit till day I. Okay. Now, what does the significance of K? So like when we have like at most K transaction, right? With, this is important, at most, because you may choose not to do any transaction also with at most K transactions. Okay. And then what is the significance of the last value? I can't draw again. Okay. When we have 0 stocks in hand, after last transaction. And what could be the last thing? When can you have the last, on this particular day, how can you have 0? Stocks in hand. How can you have 0 if you
that
sold?
means you sold. Yeah, that
Yeah.
means you sold it previous day sometime.
So today you just sold. At the end of the day, maybe you had a stock, you sold it, but maybe previous day also you had 0. You had nothing in your hand, maybe. Then you did no up. Like we defined these things here. So I'm just giving it for ideas. It is not important, but for understanding it's useful. So when we have 0 stocks in hand, after last day's operation, let's call it. Okay, now I need space. So Control Z. Now can someone help me? How can I continue to draw on the same page? Like where should I click? I want to make a space on the same page. Or it is not possible.
It is possible, I think. You should not click on the pen.
Okay.
Can you scroll through the page using your hand or no?
Oh,
No,
okay.
if you don't click
think
on
if
the
you
So first I need to unselect it, right?
yeah, if you
Yeah, if
click
you select it, it
that
automatically
symbol below insert, I think.
Sorry, can you repeat?
That symbol below insert, like next to the arrow.
So symbol, okay. This guy?
Yes, I think so.
Oh.
Now if you click
Oh,
somewhere,
awesome.
yeah.
Yeah, thank you very much. Yeah,
Sure.
that is what was very important for me. Thanks. So, okay, with that, I think we can do it. But guys, did you understand it so far? Meaning, like definition of this. This is the core part of your like
Can you
solution
repeat
of
that
this.
once more?
Yes, sure. So as we defined what was important for me on ith day, that is the reason we choose these 3 things, I, K, and stocks in hand. I was the day, K was the maximum transactions, at most transactions, which we can do. And 0 is the stocks in hand after the last operation.
So is the reason you're defining it like this, like the DP array completely captures the state of the problem at any given point in time?
Yeah, at any point of time, you have all the possible info you may need. So let's make them completed after last stop, which you just did on that day. Similarly, DPIK1 would be exactly same thing, maximum profit till day I with at most K transaction when we have one stock in the hand. Exact same story. Okay, well, let me go up. So you will have same thing. Same thing. Now, of course, just for understanding, exact same definition is the only thing. How can you have the one stock in the hand on the last day or on the ith day? Just for understanding, you can have if you bought something or you did no up because you had 0 stocks and you bought one, then you can have one on that day, or you already had one from the previous day and you chose to do nothing. So then you can have DPIK1, right? All right. So if that is clear, then we will go to the transition function, and that would be the next thing I would go to. So if there are any questions on the definition, feel free to ask now.
Could you scroll up a little bit on when it's 0, DPIK0, what
Yes.
allow operation we can have?
DPIK0. So DPIK0 means on ith day with at most K transaction, you have 0 stocks in your hand. So
okay.
Yeah, so to have 0 stock, what you can do? Either you already had 0 stock. If you already had 0 stock, then you do nothing. But if you didn't have 0 stock, you had 1 stock in this particular question, for example, then you have to sell that on that day. Right?
Yeah. But is there a way to track what day we do the transaction?
That is not
K
important.
also will be 0, right?
What was the question? Sorry.
So that means K value will be either 0 or 1, right?
You're right. Yeah, we already talked about it here. That K value. Okay, let me choose this here. Oh my God, come on. I can't choose now a pen. That is pretty bad. Can I choose any?
I think you have to unselect that that symbol, cursor symbol. Try that.
Yeah.
And then select and then can select it.
I'm clicking on this. This is what I was having issues with. Okay, so, but I need to. Okay, any other way? Control G works.
What you want to do? Sorry.
So I don't get to choose. Okay, now see it works. I think there is some magic anyway. So here is what you were just talking. We can have 0 or 1 transaction. That was actually here is that transaction could be 0 or 1.
Okay.
So we have captured these 2 possible states, right? So that's it from definition point of view. If we understand these 2 states, what do they mean? Then we can think, can I reach to these state from previous days information? If I can reach, then we will have a state transition equation, which means we have a recurrence relation. And if we have a recurrence relation, then we can actually solve it. Because there will be a base case, and then base case could be like, okay, maybe 0th day, everything is 0 or something like that. We'll discuss that later. But I
Second
will go to,
equation, can you explain? The second one, DP of IK and transaction one. Okay, once more. Yeah.
so K is transaction. K is transaction, but one is number of stocks in the hand.
Yeah, what does this do? Either you'll buy or you'll have no operation, right?
Yeah, to have one stock in hand.
Oh,
So what you are asking is about this, right?
yeah.
So that is not transaction. Transaction is here. Okay. One is what you have in the hand. Like how many stocks you have in the hand on the last day or on that ith day, basically. And
It
how
can
you can have one stock, either you did a buy or you did a no op. You already had from the previous day. And that's it, right?
Can we
that will
have
be
more?
constant. It will be constant only, right? I mean, always one only, because at
Yeah,
one
that's what
time,
I'm asking. Can we have more than one stock? I mean, if the transactions are more, then maybe we can buy in
but
the consecutive order like that.
No.
restrictions are there. Until and unless you sell that stock, you can't purchase the other one.
Yeah,
Oh, yeah.
you can have either 0 or 1.
So 0 means no stocks in hand, and 1
Yeah.
means you have bought it. Oh.
Yeah. And 0 is also important. If you want to make a profit, eventually you would like to sell it, right?
Yeah.
So when you would like to sell it, maybe your last day, then you should have 0 stock in the hand, right? Because then you will get the profit on that particular day. So yes, 0 or 1 value, that's it. It captures all the info.
How do we know by look at this equation, how do we know the no op here different than the no op, previously? Because the no op here, we assume that we already have one stock, in hand.
So
versus the top, we also assume that we have 0 stock in hand.
So this problem, or actually the class of problem, we are not asked to figure out what operation we did, right? I am explaining this thing buy or no op just for understanding purpose, because that will help you to write the transition function. But what is important, whether you did a buy or no op, does this thing uniquely gives your state or not on that particular day? Just these two values, dpik1 and dpik0. These two values uniquely tells you your current state. Doesn't matter what operation you took in the past or even today, because you are not asked about figuring that out. Like, in a lot of DP problems, you have, okay, which steps did you take to get the maximum profit in a grid, for example, right? Then you need to store those things. But if you have to just calculate maximum profit, probably you would not bother about that. You just go to that grid and see, hey, I can only come from top or from the left, and what is the maximum? Let me get from both sides, and whatever is the maximum, that uniquely gives me my state, basically, something like that. On that approach, you don't need that. Does that explain your question, Leon?
Yeah.
Okay. So should we move to the transition function? If it is clear, the definition, then actually you guys have to help. So be ready. Okay, so let's write something, transition function. So let's first write for 0. So what I'm saying, dp I k 0 is equal to, I will write some equation. So now, if you remember, just like, from top, I is the day, K is the number of maximum transactions we can have at most, and 0 is we have 0 stocks in hand, right? How can you have 0 stocks in the hand? Is either you already had 0 stocks in the hand from previous day, right? You had zero stock in the end from the previous day. So this is the no op thing I was talking about, right? To hold zero stock today, and if I had already zero stock from previous day, I would do nothing, right? I will just basically take the maximum profit which I have from previous day and I am doing nothing. But the other way I can have zero stock today is maybe I had one stock yesterday, but today I just sold, right? So what does that mean? That yesterday I had one stock. And what does that mean? Yesterday, end of the yesterday, you were holding one stock. And today you chose to sell it, and hence you made a profit of whatever was the price on that day. I mean today. So you can say price is I, right? So there are two ways you can reach to this state. And you want to maximize it. Does that make sense, guys?
I'm a little confused on the plus part. The plus prices of I. Wouldn't we do a diff of the price of the stock which we had bought on the previous day plus minus the current price and then add the profit here?
Oh, so you are saying, okay, it depends how I represent, how I show the price, like, so every transaction has two parts, right? We buy and then sell, and buying and selling together means one transaction, right? Okay, so when I will define, I mean, if you have that question, hold that question for after I define the next state.
Okay.
When I'm buying, then actually I'm already paying that charge, for example. So if a stock was yesterday at $5, so I am going to pay $5 yesterday. And if it is $9 today, then I will get that 9 today. So I will make total 9 profit. 9 minus 5, 4 profit, $4 profit.
I think state one will have that
That's,
information, right?
yeah, sorry.
State one will have that information, previous price in I-1.
Yes, that's why I want to define that, and then it will make hopefully more sense. Yeah.
I have a question. So basically in this TP array, what are we trying to store? Are we trying to store the profit, or are we trying to store the price that we are buying things or selling, like selling things, sorry, not buying?
So that was in the definition. So let's go. That was the maximum profit, if you remember. So maximum profit till day I with at most k transactions when we have zero stocks in hand. So yes, when we say anything in DP, that is the maximum profit.
Yeah, but then in that case, we would want to store the profit, right? As someone was mentioning.
I think if
That's
you
why I'm
buy,
getting confused.
just a second. I think if you buy, so you decrease the price, so your profit has also decreased. So that is a kind of incomplete state that you have done you have bought K stocks, but you haven't sold that. So the price is not yet added, but you have concurred that loss. That is what my assumption of this array.
Yes. So what we are going to do, when we are buying, we are going to pay the price. When we are selling, we are going to get the profit, right? And profit is like, as I said, suppose days were 5,
Because I think
5 and 9. So what I am saying, pay minus 5 And then when you want to sell, then gain minus plus 9. So you will make overall 4 profit.
Yeah, because ideally you'll have one more doubt because now you are selling this case. So you're not updating the transaction also. That
Oh
is
yeah,
also a trick part. So when are you, what are you considering as a transaction? So ideally, I also got that doubt. So I was also waiting when you update
yeah,
K1. So I
right.
think picture would be more.
Right. That's why when we will go through the one, then we will look at it together, then you will understand more. Because transaction has 2 parts actually. And you know, still makes one transaction, right? That's why maybe there could be some confusion.
Yeah, from the transaction equation, once you already sell the stock you hold, and that means you increase the transaction time by 1. I think it's from K minus 1 to K. Yeah.
Yeah, we will just let me just define, because that will explain a lot of problems which is going to come. Okay, let's talk about how can I have one stock in hand on today, like by the end of today, which is ith day, with at most K transaction. So one thing is no op is very easy. Okay, just do nothing because you already had it. So dp I minus 1 K and 1, right? Because everything you already had from previous day. So you just did nothing. Or I want to hold a stock. That means I need to buy a stock because I don't have a stock today. So when I am buying, then I am saying I am engaged in a transaction, right? I'm going to engage in a transaction. And that is when this guy will also change. So what will happen from previous day, I had I minus 1. Since I am saying now we are going to have at most K transaction, that means I need to have K minus 1 transaction from previous day because I am just doing a transaction today. And also, since I am going to hold a stock, one stock today, that means yesterday I had 0 stocks, right? That was the state I was in yesterday. From that state, if I buy, and when I buy, or maybe I started this transaction, I pay the price. I pay the price for whatever is the today's price. So let's call it PI. In short, the same thing. This and this is same. So now look at it. And also we want to maximize as per the definition. I want to maximize this. Now, do you have a doubt in the first definition? That's why, see, when we are selling, then we are not changing the transaction. K is here K and here K, it's same. Because selling doesn't mean a transaction, right? Because it was part of a transaction which started with the buy, but it didn't complete. That's why we are not changing that value. Any question? Feel free to ask.
So one means you are about to sell that stock, right?
One means I am holding a stock in hand. I can sell it.
Okay. And
Yeah.
K minus 1, that means you sold that stock. I mean, you made one transaction. You had one stock, you sold them. So one transaction you reduced from.
Yeah. Yeah. This is during the buy time. Here I am incurring the cost. So I need to have one less transaction, right? Then I can, because see, how can I have K transaction if I made a new transaction today? I must have K minus 1 transaction, right? Then only after this operation, my transaction number will increase by 1, right?
Can you explain once more? I didn't get.
So how can I have, say, fourth transaction. I am defining a fourth transaction. Forget about this problem. It's a generic thing. I can have a fourth transaction if I am doing a new transaction today, right? Because I am paying a price for, like, I bought a stock. If I had 3 transaction yesterday,
Okay.
does that make sense?
Yeah. Mm.
This
Yes.
is your transaction you just did, and you can only have k value of transaction if you had k minus 1 until yesterday. So guys,
Can we
feel free to
explain
ask.
where, like in the previous equation, why is the k not changing in the I minus 1 day?
That's the thing. So now transaction, you have to figure that out. You can write it in a different way. Transaction means buy plus sell. Make sense? Transaction is buying is not one transaction and selling is not one transaction. Buy plus sell is a transaction, right?
So
So
basically you can do both. So I can also buy on the same day and sell on the same day. Is that what you're saying?
no, that is not the point, and that is also not allowed in the problem, I guess. But
It will be
also,
zero
like,
once.
you will make
Otherwise, if
zero
you buy
profit.
and sell on same.
Basically, transaction is a combination of buy and sell, right? There are 2 operations. Either you can buy or you can sell. So and also you are always holding one stock in hand. That is also given in the problem. So when you have already paid for the transaction here, you already reached to a next step here, maybe. Then during selling, that doesn't mean that you are changing it. Because see, that transaction happened. Okay, now I have a stock in hand today after this fourth transaction. Next day, I want to sell it. When I'm trying to sell it, is my transaction increasing from 4 to 5? No. Even if you are, whoever is doing, like, some stock trading or something, I think the transaction fee is, I don't know, nowadays it's 0, but I don't remember if it is just one time during buy or during sell. I think it's just, I think one time thing. But anyway, that's the idea. So when you sell on a particular day, you have already, changed your transaction value. So you are not going to change it here.
Okay, that makes sense. Thank you.
Yeah, no problem. Okay, so any other question? If not, then we have enough information to solve a lot of problems now, because this is the core.
Initially, at the initial state, k equals 0, right? I mean, we
Initial,
haven't made any transaction yet.
yeah, initially you will have 0 transaction, yes. K equal to 0.
Yeah, then in here I don't see, we don't, don't see any, increment k anywhere. But then, later we decrement k, then, k would be negative.
Well, okay, your question was here, this will become negative.
Yeah, because initially k equals 0, and somewhere we do equation right here. I don't see we increase k, but at the end we decrease k by 1.
Maybe if it's, I mean, the question is, do we predefine the this dp I00 and dp I01? Otherwise, the k minus 1 is out of index.
Exactly, and that's an implementation detail. Suppose I ask you that, hey, there is a, like, recurrence relation. For example, Fibonacci. Forget about this problem, right? Fn is equal to Fn minus 2 plus Fn minus 1. What will you do? Will you run the loop from I equal to 0?
1
Probably not,
2 2.
right? You will have those 2 base cases, right? Like, okay, this is the special case. So actually it means nothing. It's an invalid state. And when you have invalid state, and if you are suppose maximizing, for example, and if you are in a like invalid state, either you have to choose a default value which suits that particular purpose, or you can choose something like, integer.min or something to make sure that that doesn't impact your overall calculation. Does that make sense? So if that was your question, in implementation, you would see actually how we will handle it. But that is, I would say that's an implementation detail.
It means like you cannot sell without buying, right?
Yes, you cannot sell without buying.
Yeah, that is what that K-1 means.
Yeah, you have to have a stock to first you need to have a stock, then you can sell. And we will see that in the example. You have code already. And also one question was, we are never increasing K. Actually, we are increasing K. If you have a recurrence relation, either in any direction, you can have from n to n plus 1 or n to n minus 1. You have a way to build up, right? Does that make sense?
Yeah.
Yeah.
So you're using K as like a counter.
Yeah, K is one of the loop can have K. For simple case, maybe not, if you have only 1 or 2 value, you can avoid that, you can optimize that. But if you have suppose 10 transactions you can make at most, for example, then yeah, you will add a loop where you will start from 0 or 1, maybe 1, because otherwise you will get index out of 1, and then you will build up. Okay. Leon, any questions?
Yeah, I'm fine.
You're good? Great. I have to make sure Leon is happy. Okay. So now, if that was clear, by definition, what should be the result in this problem? You have DP array. And if you remember the definition, it was something like ith day, how many transactions you have done at most, and what do you hold in hand? So maximum profit. So what I'm saying, if n was the number of days, then by the end of the day, with at most k transaction and with 0 stocks in hand, I will have the maximum profit. Does that make sense? Just by definition. I mean, you don't want to have 1 stock in hand finally, because every time we own a stock, we are going to lose some money because we have paid for it.
Right.
So that's your result. Yeah, with these things, we can go and take a look into the code briefly. I mean, I'm just putting it there. And also why I put the code here, so that you can go and debug yourself, because that would be the best use of my time also and your time also. And
yeah, Roger, you said that DP 0 is my answer, or 1? 0.
0 means like you have 0 stocks in hand, right?
I see. Okay, makes sense. So either you bought it or you didn't know. Okay. Oh, sorry. Either you sold it or you did know. Okay.
Yeah. Don't. Yeah. I would prefer not to think about what I did. When looking at the state, I would prefer, what does that mean? That means I have no stocks in hand, no matter how, maybe whatever I did.
Yeah.
But yeah, we should not have stocks, because if we had a stock, we would rather sell it and make more profit.
Yeah.
Cool. So with this, like whatever I have just, discussed, it is already like, here you have everything and a bit more with, like, I have also mentioned how we can have. So take a look when you have time. And I know like a lot of guys, once you have this value, uh, it's very easy to at least just try to convert it in the code. So that's what I am doing here. We are just defining n+1 day because uh, 0th day means like, before anything is started, even like, very first day, just before that also I have added one value to help me with my base case. And this one was k, so we can have either 0 or 1, so that's why it has two values. And this is our state, either 0 or 1. I can have like have a stock in hand or I cannot. And so forget about base case for now, I will go there. Just see, this is what we are doing. This is your recurrence relation ik. So I will go from 1 to n+1. K is going from 0 to 1. And remember, Leon, you were asking about it. So that's why I could have just left it, but I just made it here intentionally. If k is greater than equal to 1, then you do this. Else, don't do that. Give something very like random value, like minimum value, so that this is an like invalid state. Because you want to maximize, if you have a minimum value, you make sure that that doesn't get chosen.
So I just want to make sure I'm interpreting k correctly. So if k equals 0,
yeah,
what does that mean? That means you have no transactions remaining?
right. K means 0 means like we have done 0 transaction. Up to 0 transaction. Let's think about it. Up
It
to
means
0 transaction. Yeah.
Does it mean we have done 0 or we have 0 like remaining?
No, we have done 0. So 0 is a special. Let's think about if k was 2, then that means you have done 2 transactions. Does that make sense?
Yes.
Or at least clarifies your question?
Yes, yes.
Meaning of k. Okay.
I think transaction number changes when we sell the stock, right? If we assume like that.
From my definition, transaction changes, I think, during buy.
Okay.
Yeah.
And when you sell, it won't change.
Because the complete transaction happens when we have buy and sell. Okay. Yeah, we can do that.
Yeah. Yeah, you can see here I'm trying to sell it. So this value have always k. So transaction is not changing here. Like k in this line, everywhere I'm using k. But when I'm buying, then I have this k-1 here because I'm making a new transaction. So I will say, hey, I did a new transaction. So I'm paying a price for it. And then I can reach to this level k here with transaction k, again trying to reiterate. So on day I, with transaction k and having one stock in hand, what I'm going to do, either I may do nothing because I already have a stock from previous day. That means no change in transaction because I already had k transaction, or I am going to do one transaction. That means previous day I should have k-1 transaction.
So initially k is 0.
Yeah, and yeah, this is 0 because I was holding 0 stocks. Then only I can have one stock after.
Right, right. But in your like initialization, if you just scroll up real quick, initially k.
Oh yeah, yeah. So that's the base case. So for base case, I have a simplified version of it also, but I just wrote whatever was the transition function.
Right. For I equals 0 and k equals 0. Okay, got it.
Yeah. For every day, if we are saying that we are holding one stock, right? and I equal to 0. I equal to 0 means 0th day. On 0th day, we cannot have like one stock in hand, right? So that's why it's like, invalid state here. Also, if I don't do any transaction, no matter what day it is, can I have like IK1 means I need to hold one stock in hand, but I never did any transaction. With 0 transaction, you cannot have one stock in hand, right?
Yeah.
So that was the base case. And it was just like, if you try to submit it, it will work. And actually the next is also a simplification of the same base case. I said, hey, actually K equal to 0 means nothing because everything is 0. Why even bother doing that? Something like that. I probably like, yeah, see in this loop, I'm not even doing K equal to 0 to 1. So that's the implementation detail, which you go with your own pace. But whatever Leon was asking, that is the answer of that. Yes, if you have a good base case, you don't even need to worry about handling those cases, like because value of 0, K has only 0 and 1 value. So why even bother like doing this this for loop?
We need this when we have the K transaction, right? More than
Exactly. And that's why I left, like, maybe for 2 or maybe for K equal to K, then you will know exactly why. You just change it and it will work, hopefully. Okay. Does that make sense, guys?
where can we get this code?
Yeah, it
About
will. I will share it into our
okay, all right. Yeah.
Leetcode practice. Okay. All right.
Hey,
So
49, can you explain one more time? Sorry, I'm not getting it. Line number 49.
line number 49. 49 is this one. Okay. Okay. Okay, let's sure.
I understand that min value, but before that one.
This value, maybe this is your main thing, right?
Yeah.
Okay, let me try to explain this particular line. So this entire, and also forget about this special case, right? Because that's not your problem. You already understand it.
Yeah.
Okay. So the meaning of that line is, on day I, with at most K transaction, I want to hold one stock in hand. Okay. So the first way I can do that, if I already have a stock in hand here, right? From previous day. Sorry, what was that?
No, I said I got it. Yeah. That one I got.
That one you got already. Okay. Okay. Then this one, how can I have one stock in hand? The other way could be I bought a stock, right? And you can buy a stock if you had a 0 stock in hand previous day. Is that right?
Mm-hmm.
And also every time we buy a stock, we incur one like transaction, right?
Right.
So that means K minus 1 will be the previous day's like transaction.
It should be K plus 1, right? I didn't understand that K minus 1 thing.
Why it will be K plus 1?
Whenever we buy, we'll increase the transaction. Am I right?
Yeah.
So that means we are buying there. I didn't understand why K minus 1.
So we are building up. We are building from the previous value to the new value.
You're getting I from I minus 1.
See, I is equal to also here I minus 1, as I think Hanif was saying. See? So previous day you had less transaction, right?
Oh, yeah, I got it. That's why we have K today. So after yesterday buying it, we reached to K. That means we should have K minus 1 yesterday.
Yeah.
Okay, got it. Thank you.
Great. So with that, we have solved our first question in just 1.5 hours. Okay, so good progress today, guys. But good thing is that was the whole point of this. Like after this, you can solve next questions soon. So let me check. Let me say if I should cut down on something. So 121, I'm saying we will go to 123 next. And I may drop this idea. That was one more thing, left and right side of solution and then combine. That was basically, okay, where is that? Let me open the problem, 1, 2, 3. This problem says that it's the same problem, except you can do at most 2 transactions, right? So if you can do at most 2 transactions, then what do you think? Let's look at it with our approach. Yeah, I have already cut down one thing from my, this was another different idea, as we had like a lot of ideas for problem first, but maybe it's not that important now when we have less time. So let's look at it. So with 2 transactions, what changes? The way we have defined our equation, we have covered everything. Like we have the same transition function because we generalize it to k transaction. So no problem. Only thing is now your result would be dpn20, right? So you can even say k0, I think. Depends how I represent k, but yeah. How much profit you can get at the end of 2 transactions when you have 0 stock in hand. And if you try to just see the solution, it's exact same solution which we just had. You know, here k, here I have defined 3 values for k because I'm saying 0, I can have 0 transaction, I can have 1 transaction, or I can have 2 transaction. State is same, either I can have 0 stocks in hand or 1. And then we are just doing the same kind of loop, same initialization and same equation. Just k's value will change here with same definition. So, and that will work. Anybody has any question on this? Hopefully not, because we kind of covered the same thing. Okay. Okay, so if you have no question, that's good. We'll go ahead. Just to give you a sneak peek, which probably we'll handle later. I tried to simplify it a little bit in this case. It's just a simplification of the above code. So take a look at your leisure. And this is the final approach which we will derive when we learn about space saving thing. And just to give you an idea, it would be very easy, but I would also like to develop a little bit of understanding because it's not very easy sometimes. But see, if suppose I have this solution, for example, and please don't ask me questions about it, otherwise we will derail from the topic, but it is important. See what I'm doing, all these my array can be replaceable with a variable, and I have kept the same name. dpi10 means dpi10 here. dpi11 will mean dpi11. These are not arrays, they are variable. So you will save a lot of space when you will do that. And as I told you, I will explain maybe when we get time today, or maybe next session, we'll see how it goes. But that can give you some mechanical way to turn from multi-dimension to like 1 dimension, or sometimes even in this case, we don't need even 1 dimension. All we need just I, which was already given. So we'll go to this solution later. But just with this definition, you have a working solution for this problem. Okay. Then I wanted to do stock buy sell 188. 188 is actually the problem for which we did all this thing. Like where there could be actually at most key transaction, not just one or two or anything. Okay. So I'm showing you because anything changed here? We already covered everything. We did write the equation for the same equation, and only thing which we can say, hey, here, let's put K, because I want to get the profit after K transaction and when I have 0 stocks. And if you submit it, that's the only thing. I mean, that's why it is hard problem. I think I was getting some errors. So you may get memory limit exception, memory limit exceeded. So for that, you may need to do some special handling. And I will explain that maybe later, but let's see what we can say. This one is very clear. Like, so let me try to for folks who don't remember this question. You are given a stock price and you can do up to K transactions, and K theoretically could be infinite. So one observation is, if you have suppose 10 days and somebody is saying that, hey, the same day when you are buying, you cannot sell on the same day. Okay, that is one restriction. And if somebody is saying after that, but hey, you can do as many as transactions you want, then does that mean like you can do infinite transaction? Actually, no. You can do at the most 5 transactions in 10 days, right? You buy, sell, buy on first day, second day you sell, then buy on third day, fourth day you can sell. So if you do that optimization, then you can say, hey, actually if K is greater than n by 2, then it's of no use. Just say n by 2 is the maximum thing which I can handle. Maximum transaction I can handle. And yes, after that, we just do the exact same story which we have been doing. We initialize the base case, and same thing which we do here. Instead of K equal to 2, now we do K equal to K. Exact same equation we write, and we return the same thing. But it will time out, and it will time out. Actually, it will have memory exceeded exception most likely. So we will actually go through the space optimization, or actually other approach which will help you solve this problem. That would be discussed after we go through the space saving approach I want to take a little bit. But with that, we can go to the 122 problem. Anyone has any question? Because this was one kind of problem which we just went through. So yeah, feel free to ask me a question if you have final questions on this. Am I online, guys?
Yeah.
Okay, great. So I think there is no question. Okay. Okay, so now we will go to stock buy sell 122, and I think these problems are actually, in my opinion, easier maybe. So we'll go to this best time to buy and sell a stock. So what I would suggest, why don't you go through this? Don't look at this yet. And I will grab water, and then I will come back in 1 minute or 2 minutes, and then we will talk about it. You can think about it in the meantime. All right, I'm back. Let me grab my pen. So in this problem, we had like you can do as many transactions as you like. Same problem which we initially looked at, and just do whatever you want to do. Okay, so how do you deal with it? One way could be, of course, like since you can do any transaction, you can maybe do like a greedily make profit whenever you can make, right? And like, buy at less price and continue selling on next higher price. And that is approach may work. That approach may work for sure. So before we go through our kind of framework, let me show that approach so that in if you get this solution, you can make sense out of it. Yeah, this is the this is the approach I'm talking about. Very simple code. You are going through all the prices one by one, and whenever you see I can make a profit, just make a profit and done. That's it, because there is no restriction on the transaction, so that doesn't matter.
So this is like a greedy approach?
Yeah, I would say it's a greedy approach. Yeah.
So yeah, I guess the question I always have with the greedy approach is like, how do you know like if it'll give you the like optimal solution? Like,
Right, it's a good question. And you also know that greedy, the trick with greedy is to proving is the main part, right? Can you prove that greedy works? But so what I would have done, that I would actually, if I have to think about it, like, okay, let's take a look. If you have some price like this goes up, down, up, down, up, down, something like this. I normally put some examples and see. So suppose I was here, and I have an option that I can make a profit here, right? I can make a profit here, or I can wait and I can make a profit here, right? Because that would be like, higher price, right?
Yeah.
But look at it. If I don't choose to make a profit here and I wait for something in future, then you can have two cases, right? You can have a case like you may lose this one totally. You can just make whatever was this delta. For example, if it was 2, this was 4, and this was 6, for example. Then if I go from 2 to 6, I can make profit 4, right? Other approach, I could say, hey, why not make 2 to 4, well, so means profit 2 now, and then price decreases, say this is 3, and then make profit 3 here is equal to 5, right? Things like that. If not, then maybe you have this kind of, maybe it was not 3, suppose this was 5. That could be the case, right? It was going up, and then maybe 6, just to make 6 a little bit above, it was going up and up. Then also you are not losing anything, you can still have it, because what I can say, okay, 2 to 4 make that profit, and then 5 to 4 again make one profit, then 6 to 5 again make one profit. So basically you are going to make profit, equivalent profit, profit.
yeah. So I think the key thing is the last sentence in the problem description, where it says you may not engage in multiple transactions at the same time. So you can't like buy multiple times before you sell at the maximum price. for example.
Oh yeah. That is in the question. That's right. So that could have been one other approach. And so
yeah, so without that restriction, I think there could be like cases where that wouldn't work. Okay.
Yeah. Now also one very important thing, I showed this solution, and if you think about the previous problem where we were doing the k at most k transaction here, to 188. So here, your first case, when we are given like something, you can do as many transactions as you want somewhere. No, like infinity transaction means basically the same thing, right? So you could have especially handled using the same logic, which I just showed with that. I haven't shown it here, but what I'm saying, when I will talk about optimization, maybe in this piece of code, I'm still using DP, but you can just do the greedy thing and most likely it will work right away. This exact same logic, because it is a sub problem of that problem also.
With the greedy thing, I don't see you check if the profit is greater than 0. So could it be you also include a negative profit?
No, it's only checking if the price I is greater
Oh,
than
okay,
price I
yeah.
minus.
Sorry,
Yeah.
The only place this greedy will not work is where we have a, let's say, transaction fee, because here we are just trying to kind of basically ride on all positive wave, irrespective of transaction. Basically, the transaction is at the minimum I am buying and maximum I am selling, right?
Mm-hmm.
All the slopes, basically, all the upward slopes.
Yeah. Okay. So with that, so yes, now what was the point was that, okay, this one, now we to continue to use the exact same approach, right? And here I want to write on the board, but it takes time, so I will go through here anyway. And also I will choose board sometimes. What I am saying, and that is where I differ from the Leetcode discussed post a little bit, that whenever you are given k is infinity, it loses meaning. Why it loses meaning? That in any DP or any these kind of problems where values are changing, but that doesn't mean anything for your state. It doesn't matter how many transactions I can make. Then I can just drop it from my state for all practical reasons. Don't think about it at all. So what I am saying, and you will see that that solution works, is I can totally drop this dimension, this k dimension, because k is up to infinity. It loses meaning for me because there is no restriction put there. So now with that in mind, we'll solve problem best time to buy and sell a stock. And there are actually 3 problems. So like 122, and then maybe with cooldown, it also has, you can do as many transactions. So you will see exact same thing, that from 3D, I will directly go to 2D. And with transaction fee also, you can do as many transactions. So I will also go through that. So this is where I differ from that article. Because I like to have less state.
So in the article, they don't drop the k dimension?
No, they try to define things mathematically. So if you go ahead, and a lot of people may get confused a little bit, what they will say, hey, actually k, and if k is infinity, then k minus 1 also means infinity, but in certain cases it does, and in certain case it means something else. It is right, but there were lots of I lost some intuitiveness there.
Yeah.
And to me, yeah.
But I
what I
think
was
that definition
thinking,
covers the at most k transaction also. So if we don't have that problem, then dropping that makes sense. But if we have that k, then we can cover all the cases irrespective of.
Right. But suppose if you have k transaction and k is infinity, then can you solve it? Think about it.
what I was thinking is if k is infinity, k, as you said previously, it's still capped at like n/2.
Maximum number of days.
Yeah.
Yes,
That
but I agree with you that it's like if we can solve it by dropping that dimension, then like obviously we're saving
yes.
space and it'll be a better solution.
Right. And exactly, I did the same thing. That's why in a couple of examples, I intentionally showed that approach that, hey, this means this, you can still do it. But then this idea came that why not just drop it? So we'll go through it.
But we
You guys
cannot
all
drop for the at most k transaction, right? Or can we drop for that also?
know with at most k transaction, uh, actually, yes, I can show you, but I think we should look at it later.
Okay.
Yeah.
I'll look at that.
So just for visual thing, let me show you here. So in if you are looking at the code later, see this special handling, you can see I have reduced to a 2D, and this is what I'm going to explain now.
Okay, because we are using only k minus 1, so we can have the variable to that one array to hold that, something like that, right?
So if k is greater than n by 2 means it's an infinity case, right? I can do whatever with my transactions. I can have as many as transactions, and in that case, what I am saying, two approach. Either you can say k equal to n by 2, which I did in the previous approach here. If you see, this is I did in previous approach somewhere here, maybe here. I still have 3D thing. I still went through the exact same solution which we are talking about. But when I was trying to optimize for space because memory complexity was going high, I said, why not I just get rid of k altogether? I don't want to have that dimension in my solution. And that's why you will see here there is no k in this particular case. And this problem has two cases. Either k can be infinite or k greater than n by 2, which means infinite in theory, or the regular case which we talked about. So regular case, we have already went through that solution, right? Any question on that? And I'm going to explain this approach, and you will be easily, you can make a sense out of it when we will go through one of this, where I drop k and see how it works. So we continue?
Yeah.
Okay, if there are no problems, okay, let's go ahead. So here, let's drop k. Then what is the meaning? Okay, then I will just drop k from my state. DPI0 means maximum profit till day I when we have 0 stocks in hand after last operation. Sell or no op because you have 0. Same with 1. We are just ignoring k anywhere. Just look at it. Transition function will be same. I can have 0 stocks in hand if I already have a 0 stock from previous day, or I have 1 stock from previous day, but I sold something today. Then I will I will have 0 stocks in hand by end of today. So that is that. Same thing here. DPI1, this is where you were having k minus 1 transaction, and look at it. You will have 1 stock in hand. How you can have 1 stock in hand? If you already had a 1 stock in hand from previous day, or from previous day, you had 0 stocks in hand, but today you plan to buy 1. That's it. No, nothing about k. We are not thinking about it. And still result will be same. We just ignored k, same thing, base case. And now what you are going to do, you have that already. You forgot about applying that k loop here. and you have the solution. So what I'm saying, you are not changing the formula. You have exact same formula. All you have saying, wherever you have K, just drop it because it doesn't make sense. And also, like, it doesn't make sense from a conceptual point of view. If things are not changing, right? Why would that be part of my state? Part of a state is like, the things which may change, right?
But how do we prove that, that's we can do at most K transaction in here? If
No,
not,
here
completely.
you are not asked that you can do at most one transaction, at most K transaction, right? See, here, all these questions you are saying as many transaction as you like.
Okay. Or we don't make any transaction. That's also mean we at most we do at most.
Yeah. So as long as you have more than n by 2 transactions allowed, then you can totally ignore K, because that means you can do as many transactions as you like, because that is the maximum limit. In this problem, it is clearly said that you can do as many transactions as you like. So you don't need to worry about it. You can
Okay.
just do it. Make sense?
Yes.
Okay, if that makes sense, then isn't this more simplified? Like, why to think about, all this thing? So yeah, that would work. If you try to submit, this will work for sure. And let me see the next question. I think I may remember. Next problem I want to talk about is this one actually, because this is easier. This problem is exactly same problem. You may complete as many transactions as you like, but you need to pay the transaction fee for each transaction. Okay. Okay, so if you can do that, the only thing which is changing is while I am buying it, now I have to pay transaction fee also, right? Nothing else changed. I can do still as many transactions as possible. I still want to make this maximum profit. Nothing else changed. So with the same definition, what I am saying, hey, when you are buying, now you are not just paying for the price of the stock, you are also paying the fee every time you start a transaction or every time you buy something.
So you pay fee only when you're buying, not when you're selling?
Yes, because again, same thing, transaction. Your transaction means combination of buy and sell. So
Okay.
yeah, during buying, it means that I'm starting a transaction. So I pay here. The what changed? Only this line changed. What implementation changed? Only this line. That's it. See, this just one value minus fee, and you're returning the same thing. Okay.
And in this case, fee is constant always. But even if, like, let's say fee changed every day, then we would just do like fee of I.
Yeah. If the price of fee also is dynamic, then yes, on that particular day, whatever was the price, you will do fee of I, or maybe I minus one based on how we do, right?
Right. Yeah. Right.
Yeah. Something like that. That should work.
So this
So
solution, either we consider the fee while selling or buying, both should give us same result, right?
yeah, you can do that in your state equation, like, but just don't duplicate. That's the main point.
Okay. Yes. Makes
Yeah.
sense.
If you are paying during buy, then just do that, or pay during sell just once, and then that should work. I haven't tried, but it must.
Okay. So to that point, what Hanif is saying, then that time that should be clear things whether the fee apply to buy or sell. Then it become a little bit more complex, because if the fee is changing daily, then if he is applying at the buy or sell, that okay, only one time, right? You can't choose where you pay the fee. Either it is buy or sell.
Yeah.
Yeah, okay, makes sense.
And now here, this is kind of similar problem. Here, there is one more constant. Here we are saying you may complete as many transactions as you like that buy one and sell one share of the stock multiple times with the following restrictions. You may not engage in, this was already told that we will have only one buy and sell, but also after you sell your stock, you cannot buy stock on the next day. That is, you will have a cool down of 1 day. So what does that mean? On ith day, like I cannot buy a stock if I sold something on I minus first day, right? Because every time you sell the stock, you wait for 1 day because maybe like, something takes time maybe to handle that situation. We are just saying with cool down, here is the case. We cannot buy on ith day if a stock was sold on I minus 1th day. So with that in mind, let's see how our state will change. We have exact same definition. Since again in finite case, we are ignoring K altogether, okay? So, okay, let's talk about how can I have zero stock in hand on ith day. So I can have zero stock in hand if I already have a zero stock in hand. I did nothing. Or I had one stock in hand previous day and I sold and made a profit today, right? There is no restriction because I had in this case, there is no restriction. I had a stock in hand and uh, so that doesn't mean that, I'm engaging in any cool down doesn't affect me in that particular case basically. But here, see, what I want to do, I want to get one stock in hand. So easy case first. I already have a stock in hand from the previous day. It's a no off for me. But today, other way I can have a stock in hand if I buy one. But when I buy one, I have this restriction that I cannot buy today if something was sold yesterday. So I depend on previous to previous days. Like I had zero stocks in hand, not yesterday. Previous to previous day, I should have zero stock in hand. Then I can do the buying today. I'm allowed to do as per this second rule. If you see, does that make sense?
Yeah, got it.
How does that capture if you sold on the previous day? Like it's like two possibilities. Either you sold on the previous day, in which case you cannot buy today, or if you did not sell on the previous day, then you can buy today. Like how is that being captured in that line 8?
So in line 8, okay, first case is clear, right? Let's not think about it.
Yeah.
Right? What is my state? That I want to hold one stock, right?
Yes.
Right. What is the option I can do? Like if I from previous day, I already have one, that is fine. But if I don't have one, right? So can I do anything with I minus 1, 0? Can I? Because see, our thing also means like last day, if I say something is 0, that means last day I did a sell. So I cannot say I minus 1, 0 here by definition.
Okay. Yeah, I think, yeah.
So you are only allowed if you go 1 day back, and even if you did sell, you can buy now.
Okay.
And then you have this thing, same result, same base case. And with that, you write this thing, the only value which changes is here, I minus 2 here. And as Leon was saying, that just check for the base case, like, don't get array index out of bound exception here. And that's it. So with that, if there is no question, we have kind of concluded.
This is minus price I or I minus 1?
Okay, let's look at it. This is minus price I minus 1. Maybe it's best case. Yeah. What does that mean? Let's see. Okay, yeah, makes sense. What I'm saying that in the beginning, if you want to hold a stock before I minus 2, if I minus 2, then it's fine. Like you can buy something. But before I minus 2, what you are saying, you have a negative value of the price from previous day. Because this value will be 0. This value will be 0.
So price I minus 1 or price I, because the equation says above in the comment, it's price I.
Yeah, so that's a little bit, actually, I could have fixed it, but it's good that you looked at it. I'm starting with one index. So every time I see I minus 1, that means the 0th day.
Okay, got it. Yeah, because we have the 1 plus array.
Yeah.
Yeah. The price is of ith position. Yeah.
Yes, price at ith position. So yeah. So with that, we have handled the core idea of that thread, and we have solved all the questions except one optimization on question number 4, which will still work with this approach, which we just talked about. Now, if you look at it, when k is greater than n by 2, we turned it up into like 2-dimensional problem, and then that may work. But to get even better, I think response time, I think we can do some space optimization thing, and I don't think we will have time today for sure, but let's see what we have. We have covered every problem. So in my agenda, I was saying differ space saving solution, which I did. Then I was about to give you general idea, and it is a bit advanced topic. In fact, I applied it on today's Leetcode challenge problem also a little bit.
I think from what I glanced from your code, the impression I got was since most of these recurrence relations only depend, like the ith day only depends on the ith minus 1 day. So instead of like saving the entire array, you're at any point in time, you're just keeping track of that previous day.
Yeah, totally makes sense.
And then, okay, yeah, cool.
Yeah. If I had time, I would have explained using drawing, like, I can't do a 3D drawing, but I tried my best. But yeah, it's like, if I have to show it, maybe I can use my notes someday. But then also I wanted to see, like, in one discussion, we talked about knapsack, like people write 2D solution very easily, but when they say, like, 1D solution with just one row, it becomes tricky. So I had that. And then after that, I would have applied all this to all the problems we had today. But as you know, there are too many things. So we'll see. Do you guys have any questions or anything to talk about this approach? Because we can't handle all those things today for sure. And also, I will only do if it is actually, like, somebody is very much interested, because I consider it to, like, do it if you have a solution already, then think about a space optimization. If not, don't think about it. For example, like today's longest, common subsequence, I first wrote, like, brute force to, like, 2D thing, right? And then I saw, hey, it depends only on I-1, J-1, and then I-1J, basically diagonal and the one above top on the left. Then I said, okay, let me just turn it into 2-row solution. So here I changed it to, instead of MN, I just made 2 rows, and then I can switch back and forth between that to populate the state. But there are some solutions which, I mean, like it could be on my scratch pad. Yeah, like knapsack. So knapsack, what I did, I don't know, knapsack, it's the classic problem. So this is 2-dimensional problem. Again, I've made it to, for example, 2 rows, and I would have explained, or maybe I will explain with picture later, 2D, but actually in this problem, you can also just do everything in 1D. How does that work? And why I should go from, like, from this side, capacity to, like, 0 rather than C0 to C less than capacity? Why should I go from the end of the array versus the start of the array? So all those questions I had planned for this general idea example of a space saving. Just giving you a sneak peek. But yes, that's it. And we are all.
So again, I'm asking, I don't see the link to the solution in the channel.
Yes, I didn't share it because I want to become popular, right? People ask me, then I feel it, it's better. I'm just joking.
Now you're
Yes.
popular. You
What?
can share it. Now you're popular, you can share it.
Yeah. I'm just joking. Yes, I will. Actually, yesterday I was fighting with my laptop for a long time. Some Windows update, like, I was not even, some of the solution I couldn't code up. So anyway, now I will just put everything somewhere.
Yeah.
Roger,
Just in the GitHub.
yes, I was about to say that, Roger. Do you think it is better if we put in the GitHub? That way it will be there forever. We are putting our all the other code there. I can send you the link, and then probably you can create a pull request there.
Yeah.
But in the channel, it will be easy to link. Like we can just directly go there. Otherwise, we have to look into the GitHub.
Yeah, I think go ahead. I think let's stop the recording first, because now we are stopping this, right?
Right.
So let me stop this here, and let's stop the record.